Hello everyone, welcome to my YouTube channel. Let's continue with Leetcode 237, delete a node from a linked list. So we're seeing from a problem scope that we're given a singly linked list. So this is a singly linked list in that our linked list does not have a previous pointer. It just points to the next item in it. And we're given the node to be deleted. We will not be given the access to the first node of the head. Now, this is very important point. We will only be given the node to which we are to delete. We can be guaranteed that all linked lists value are unique and that the given node is not the last node in the linked list. So we can see from the diagram that we have a 4, 5, 1, and 9, and we are asked to delete the node 5, the node with the value 5, right? So we're not giving access to the edge. The edge basically refers to the first item in our linked list, but we're not giving access to this. We're just giving access to the value we are to remove, and we can tell from the problem that's what the value we are to remove is not going to be the last value. So deleting the given node, what does it mean? It means that we remove it from memory. Basically, it doesn't exist in our linked list anymore. So our return value should be 419. 5 should no longer be returned in the value. The number of the nodes in the linked list should decrease by 1, which is obviously the one that we removed. All of the values before the node should be in the same order. So we are not going to be changing the order by which we receive our linked list, and all the values after the node should be in the same order. Essentially, if we remove 5, 4 should stay the same, 1 and 9 should stay in the same position. We should not do anything to change that. Now let's look at how we might solve this, and it's actually simpler than you might think. So we are given the constraint of not giving the head node. If you are familiar with linked list, you would know that the best way to access a given node in a linked list is to traverse the node. So we're going to be traversing, or we would have traversed every element in the node, and whenever we find an item that is equal to the given item. So let's say we are traversing our node and we find an item that is equal to this item. So we check where we are currently at, is it equal to the guy we want to remove? If this is a true, then what we are going to do is we want to access the next pointer. Recall that nodes are connected by a pointer next. So we want to change the pointer from this guy here straight to this guy, essentially losing this guy. We are breaking off the pointer here. We are breaking off the pointer. That is what a linked list is. It's connected by a pointer essentially. And whenever we find an item, we just break off the pointer and move on to the next one. So we would have easily done would have really done a while loop and check if the current, this would have been our current, done next, the current done next, the next would have been 5. If the value in this is equal to the value we are asked to remove, then would have changed the pointer from this. So the current dot next, from here we should no longer point to 5. Instead, it should point to current dot next. So we're skipping this dot next and moving on to the next value. Now, how do we undo this if we do not have 5? If we do not have the head, basically, we're just giving the node to be removed. So we know that the way a linked list is structured, we only have access to the rest of the item in our linked list, given the head of our linked list. If we are not given the head, then we essentially cannot traverse our list. So we have to solve this problem by not traversing, which is what we are going to do. So we know we want to overwrite 5, and we also know that the way to lose access to a value in our linked list is by breaking off the links to it. So what we're going to do is we're going to replace the value we are giving. So we are giving the node to be removed, right? So we have access to the node and the node after it. That is all we have access to. We do not have access to previous node because it is a singly linked list, meaning it doesn't point the other way. It only points to the next item, not the previous item before it. So what we're going to be doing in our code is essentially replacing this value by the value of the next item to it. So we are giving node, our node now becomes node dot next. Essentially, we are replacing the value, and we also want to break off the pointer. So once we replace 5 by the value next to it, which is 1, so 1 comes here, we no longer want to point to 1 because we just replaced the value of 5. Instead, node dot next is no longer going to point to 1. It's going to skip over 1 because, again, 1 already replaced the node that we want to remove, and it's going to point over to the next value in our linked list. And we can be sure that this is not going to throw some weird error because we're informed that node is not going to be the last item in our linked list. If it was going to be the last item, we could have easily checked that if there is a next dot next, return a null. But since that caveat is not there, we can easily just um do away with that. So for complexities, the time complexity here is basically constant. All we are doing is deleting a single node in place. We are not traversing the entire list because we do not have access to the head, and we are also not using any extra memory. We are just removing a simple node. Now let's jump right into the code and see what that looks like. So this is our playground and we're given the node that we want to remove. What we want to do is access the value property in node. As you can see, this is the structure for the linked list node. And this is also a good point to say that if this structure is a bit confusing, what is linked list, what is pointers, this is a good point to actually look up what a linked list data structure is, how to create one, how to add and a node to a linked list, how to traverse linked list, and how to delete an item from a linked list. These are the basic operations we do with a data structure: creation, adding, deleting, removing, traversal, I think searching and inserting. So you need to know those basic operations before solving linked list problems. That definitely makes it easier. So now we want to set node the value to the value right after it. So we're basically overwriting that. Note the value is going to be overwritten. And since note the value is already the next value after it, we also have to break off that pointer so we do not have a repeated um value in our linked list that would throw an error. So the next is going to definitely move 2 steps further. And now I'm just going to run this, see what that returns. Everything checks out. Now we can go ahead and submit our code. All right, I hope this was helpful to you in some way. Do check out some other videos to keep on practicing Leetcode. And again, if this question was a bit of a stretch to you, then you need to play around with linked list as a data structure concept. See you in the next video. Thank you for watching. Bye.